Question 1. Through the lens of thermodynamic performance, Mr. Alston is troubleshooting a roof-up HVAC unit operating with a lower than expected temperature differential across the evaporator. He observes normal suction pressure but slightly elevated superheat. The ambient temperature is 88 degf and the evaporator inlet temperature is 46 degf. The return air is 78 degf dry bulb. He suspects an airflow related issue but is unsure whether the problem lies in heat transfer or refrigerant metering. What should Mr. Alston investigate first to isolate the issue? A. Check the refrigerant charge to ensure it matches the system's specifications. B. Inspect the TSV bulb placement and insulation for proper operation. C. Evaluate the evaporator coil for reduced airflow or blockage. D. Confirm the compressor amperage draw against rated conditions. Answer. Correct answer. C. Evaluate the evaporator coil for reduced airflow or blockage. Explanation. Low DT across the evaporator combined with elevated superheat and normal suction suggests poor heat absorption, often due to reduced airflow. Desi coil or clogged filter limits air volume, causing poor evaporator performance. According to HVACR Manual RS and ASHRAE fundamentals, airflow issues are primary cause of low system efficiency and misdiagnosed refrigerant problems. Checking charge without verifying airflow may lead to incorrect adjustments. Question 2. From a practical standpoint, a technician named Rebecca is recovering refrigerant from a large chiller system over 50 pounds. Charge. The recovery cylinder is nearing 80% full based on the site gauge. The ambient temperature is 85 degf and she's using recovery machine rated for high volume liquid recovery. What must Rebecca do before continuing the recovery process? A. Add second recovery machine to speed up the process. B. Switch to new recovery cylinder that is properly rated and empty. C. Open the cylinder pressure relief valve to vent excess pressure. D. Subcool the cylinder using ice water to allow more volume. Answer. Correct answer. B. Switch to a new recovery cylinder that is properly rated and empty. Explanation. According to EPA 608 and RE Guideline K, a recovery cylinder must not exceed 80% capacity at 130 degf. Continuing to fill an 80% full cylinder is safety violation. Venting is illegal, and subcooling may temporarily reduce pressure but not volume constraints. Rebecca must switch to new MP recovery cylinder to maintain compliance and prevent overfilling. Question 3. While examining a rooftop unit schematic, a technician notices that the fan motor is not operating despite a call for cooling. The 24 control signal is present at the contactor coil, but the contactor is not engaging. Upon testing, the control transformer shows 24V output, but no voltage is found across the contactor coil terminals. Which of the following is the most logical explanation for the failure? A. The contactor coil is open or has failed internally. B. The compressor overload is tripped, interrupting control voltage. C. The thermostat is malfunctioning and not calling for fan operation. D. The transformer is underloaded, preventing proper function. Answer. Correct answer. A. The contactor coil is open or has failed internally. Explanation. Voltage of one coil terminal but not across both terminals indicates the coil itself is open or the return path is interrupted. This fault is consistent with a failed contactor coil. As per NEMA guidelines and standard electrical troubleshooting procedures, NEC Article 430, the next step would be to verify coil resistance Ohm's law application. Other options are either irrelevant or already disproven by initial voltage tests. Question 4. As illustrated by a recent multi-zone heat pump installation, technician Lorenzo is overseeing the commissioning phase of a 5-head ductless mini-split system. He observes that only 3 indoor heads respond to cooling commands while the remaining 2 stay inactive despite proper piping and wiring. System pressures are normal, and there are no fault codes on the outdoor unit. What is the most probable cause of the issue? A. The indoor heads are improperly addressed or not assigned to the controller. B. The refrigerant charge is insufficient for full multi-zone operation. C. The indoor units have faulty expansion valves. D. The outdoor unit is undersized for all heads operating simultaneously. Answer. Correct answer. A. The indoor heads are improperly addressed or not assigned to the controller. Explanation. Multi-zone mini-splits require each head to be uniquely addressed and configured in the outdoor unit's control logic, according to manufacturer startup procedures, e.g. Daikin Mitsubishi failure to assign IDs causes certain heads to remain inactive. Normal system pressures and no air codes eliminate refrigerant or mechanical faults. Proper addressing ensures synchronization and correct zoning logic. Question 5. Taking into account a recurring freeze-up issue, Mr. D'Souza is evaluating walk-in cooler that repeatedly forms ice on the evaporator coil despite multiple defrost cycle initiations. The defrost timer functions properly, and the drain pan is clear. He notes low superheat and extremely low suction pressure. What action should Mr. D'Souza take next to resolve the issue? A. Replace the evaporator fan motor to improve air circulation. B. Verify and adjust the TXB for possible overfeeding. C. Shorten the defrost cycle duration to prevent excess heat. D. Increase compressor capacity to stabilize suction pressure. Answer. Correct answer. B. Verify and adjust the TXB for possible overfeeding. Explanation. Low superheat and low suction pressure suggest the TXB is overfeeding, causing refrigerant to flood and reduce coil temperature below freezing. Even with defrost cycles working, continued ice accumulation indicates a metering fault. Per Emerson application engineering bulletins and RCS troubleshooting protocols, TSV diagnostics must include bulb position, sensing pressure, and valve response. Overfeeding reduces refrigerant vaporization, which promotes freezing. Question 6. When analyzing mixed air conditions in a valve system, which factor most significantly influences the resulting dry bulb and relative humidity values at the coil inlet? A. The outdoor air damper position and mixed air temperature. B. The cooling coil surface area and refrigerant type. C. The air velocity across the filter section. D. The pressure differential between return and supply ducts. Answer. Correct answer. A. The outdoor air damper position and mixed air temperature. Explanation. In systems utilizing economizers or fresh air dampers, the ratio of outdoor air to return air directly affects the mixed air temperature and humidity entering the coil. According to ASHRAE Handbook, HVAC applications, psychrometric calculations depend on mass and enthalpy balance. Adjustments to damper settings alter the air mixture ratio, influencing coil load and performance. Other factors affect flow or pressure, but not primary air properties. Question 7. By evaluating a system under peak cooling conditions, Mr. Noland uses manifold gauges and finds a high suction pressure and a low discharge pressure. The superheat is minimal and subcooling is negligible. He suspects refrigerant flooding or compressor inefficiency. What test should he perform next to validate compressor performance? A. Megohm test of compressor windings. B. Compressor amperage comparison against nameplate. C. Discharge line temperature and compression ratio analysis. D. Check filter dry pressure drop for restriction. Answer. Correct answer. C. Discharge line temperature and compression ratio analysis. Explanation. A compressor's performance is best verified by examining the compression ratio, discharge suction absolute pressures, and discharge line temperature. Low ratio indicates poor compression, possibly from worn valves or scroll failure, as per Copeland and Bitterfield guidelines. This analysis determines if compression is adequate. Electrical or filter checks directly assess mechanical compression ability. Question 8. To illustrate this point, a technician is calculating the cooling load for a 2500 sq-ft office with significant internal gains due to lighting and equipment. The building has single-pane windows with direct afternoon sun exposure. Which factors should be prioritized to ensure accurate heat load estimation? A. The local wind velocity and its infiltration effect. B. The sensible and latent internal loads from occupants and equipment. C. The wall insulation thickness and framing material. D. The color of the exterior roofing material. Answer. Correct answer. B. The sensible and latent internal loads from occupants and equipment. Explanation. Commercial spaces often have high internal gains due to electronics, lighting, and occupancy. Per a CAM Manual N and ASHRAE 183, accurate load estimation must include both sensible and latent loads from internal sources. While infiltration, insulation, and reflectivity matter, internal load dominates cooling sizing in high commercial zones. Ignoring this results in undersized or poorly performing systems. Question 9. Based on the information observed during a service call, Mr. Jensen notices fluctuating CO and O readings in commercial furnace combustion analysis. The draft pressure is consistent and there is no visible flame rollout. However, the flue gas temperature is abnormally low. What is the most likely cause of the readings? A. The primary air shutter is stuck in the closed position. B. The heat exchanger has internal cracks or corrosion. C. The gas pressure regulator is improperly adjusted. D. The burner orifice is partially clogged. Answer. Correct answer. B. The heat exchanger has internal cracks or corrosion. Explanation. Cracked or corroded heat exchangers allow secondary air dilution, leading to inconsistent combustion readings and low flue temperatures. As per NFPA 54 and ASE's combustion protocols, this is a serious safety issue. Stable draft and flame behavior suggests combustion air is not the problem, but infiltration into flue gases is. CO levels also fluctuate in such cases. Question 10. The growing trend in variable air volume valve systems has led technician Maria to reassess airflow balance in a renovated commercial office. She notes that one zone receives insufficient cooling despite a new valve damper installed. Static pressure readings are erratic in that zone and airflow velocity seems low. What should Maria do first to correct the imbalance? A. Replace the zone's valve damper actuator. B. Inspect and adjust ductwork for excessive bends or leakage. C. Reprogram the building automation system BAS to reset airflow targets. D. Install a booster fan to increase zone airflow. Answer. Correct answer. B. Inspect and adjust ductwork for excessive bends or leakage. Explanation. Improper duct layout or leaks increase resistance, reduce effective airflow, and cause pressure fluctuations. ASHRAE 111 and SMACNA standards emphasize proper duct routing, sealing, and minimal bends for valve performance. Before replacing actuators or adjusting BAS, mechanical deficiencies should be ruled out. Booster fans are last resorts after addressing duct design flaws. Question 11. When faced with a dissatisfied customer, technician Alina visits a commercial site where the occupant complains that the air conditioning system never reaches the set point. Alina confirms the thermostat is calling for cooling and the system cycles on and off correctly. However, she notices the thermostat is placed on an exterior wall exposed to afternoon sun. What should Alina recommend to address the customer's concern? A. Replace the thermostat with high-accuracy smart model. B. Relocate the thermostat to an interior wall away from heat sources. C. Add insulation behind the thermostat to buffer the radiant heat. D. Increase the cooling set point to compensate for radiant gain. Answer. Correct answer. B. Relocate the thermostat to an interior wall away from heat sources. Explanation. Thermostats should be installed on interior walls away from direct sunlight, vents, or appliances. According to ASHRAE Standard 55 and manufacturer guidelines, radiant heat causes false temperature readings. Replacing the thermostat doesn't fix placement. Buffering or adjusting set points are temporary workarounds. Relocation ensures phase control. Question 12. The correlation between voltage imbalance and motor damage becomes critical during commercial compressor troubleshooting. Technician Aaron discovers a three-phase scroll compressor drawing excessive current on one leg. He measures a 6% voltage imbalance between phases at the contactor. What should Aaron do before condemning the compressor? A. Check the supply transformer tap for balanced voltage output. B. Replace the compressor with a more robust design. C. Reset the overload protection and test again. D. Swap two power legs and check for balanced draw. Answer. Correct answer. A. Check the supply transformer tap for balanced voltage output. Explanation. Voltage imbalance greater than 2% can significantly overheat motors and void warranties per NEMA MG1 and DOE guidelines. The issue often lies upstream. Bad transformer taps, loose terminals, or utility feed imbalance. Swapping legs only masks the issue. Current imbalance is symptom, not the root cause. The compressor may be fine. Question 13. Contrary to popular belief, switching from R22 to a drop-in alternative is not always straightforward. Mr. Viga is retrofitting residential split system from R22 to R438. He replaces the filter dryer and confirms charge weight and pressures are nominal, but after startup, the system shows erratic superheat and oil return issues. What is the most likely cause of the problem? A. The system's metering device is incompatible with the glide of R438. B. The TSV is stuck closed due to contamination. C. The suction line is undersized for the alternative refrigerant. D. The compressor lacks sufficient torque for high glide refrigerants. Answer. Correct answer. A. The system's metering device is incompatible with the glide of R438. Explanation. Refrigerants with high temperature glide, like R438, 7-deg, can misbehave with fixed orifice or improperly sized TSVS. The varying evaporation temperature affects valve modulation. ARIA guidelines warn about replacing ESVS during retrofits. Glide affects superheat control and oil return, especially in long-line systems. Question 14. During the process of commissioning a new rooftop unit, technician Malik observes that the system short cycles frequently. Pressures and airflow readings appear normal. After further inspection, he determines that the crankcase heater was never wired correctly during installation. How does a non-functioning crankcase heater contribute to short cycling? It leads to overfeeding by the expansion valve. B. It prevents proper subcooling in the condenser. C. It causes refrigerant migration and liquid slugging at startup. D. It interferes with the thermostat logic via ambient temperature shift. Answer. Correct answer. C. It causes refrigerant migration and liquid slugging at startup. Explanation. Without crankcase heat, refrigerant migrates to the compressor crankcase during off cycles and condenses. On startup, the liquid slug can cause mechanical stress, forcing the overload protect to trip. This results in short cycling. As per Emerson and Copeland application engineering bulletins, crankcase heaters are essential for oil protection and reliable operation. Question 15. Examining the consequences of poor ladder setup, technician Claire sets up a 10-foot ladder to service a wall-mounted mini-split in a narrow corridor. She leans the ladder slightly on the indoor unit casing for balance. What risk does Claire introduce by this setup? A. Electrical shock due to proximity to wiring terminals. B. System contamination by disturbing insulation. C. Personal injury due to ladder slippage and equipment collapse. D. Fire risk from compressing refrigerant lines. Answer. Correct answer. C. Personal injury due to ladder slippage and equipment collapse. Explanation. Per OSHA 1910 subpart D, ladders must be used on stable surfaces and must not be supported by equipment. Leaning a ladder against a mini-split casing is hazardous and can lead to collapse or falls. The indoor unit is not designed to bear weight. The proper use of step ladders with full leg support ensures technician safety. Question 16. The development of a consistent diagnostic method is crucial in solving intermittent faults. Mr. Alvarez receives a call that a reaching cooler sometimes fails to maintain temperature, but the issue resolves itself before he arrives. Logs show that once every few days the unit runs continuously without cycling off, which step best helps isolate the fault. A. Replace the thermostat and pressure control as a precaution. B. Install a data logger to monitor temperature, cycle times, and voltage. C. Switch the cooler to manual defrost mode and monitor. D. Measure evaporator superheat at 15-minute intervals manually. Answer. Correct answer. B. Install a data logger to monitor temperature, cycle times, and voltage. Explanation. Intermittent faults require long-term monitoring. Per says diagnostics and NIST HVAC data analysis protocols. Data logging offers time-based insight into trends and failures not visible during site visits. Replacing controls blindly is discouraged. Manual readings won't capture transient issues. Logging validates control. Performance anomalies. Question 17. The central argument for proper plan interpretation arises during duct installation on a medical office renovation. Technician Darren follows the blueprint but notices return air grills are located directly above high-sensitivity exam tables, contradicting standard design practices. What should Darren do upon noticing this conflict? A. Install as shown, then document the conflict for inspection. B. Move the return grills to a sidewall near the floor. C. Notify the project engineer or architect for clarification. D. Cap the existing returns and install new ones at his discretion. Answer. Correct answer. C. Notify the project engineer or architect for clarification. Explanation. Technicians must follow mechanical drawings but should communicate potential code or comfort conflicts as per ASHRAE 170, healthcare ventilation and standard project management protocol. Changes must be approved by the design professional. Unauthorized relocation violates scope of work and may create liability. Coordinate. Critical in healthcare projects. Question 18. From multiple perspectives, Istasing evaluates a condensing gas furnace with excessive condensate buildup and short burner runtimes. Combustion tests show normal KNO and flame appearance is good, however condensate overflows during long runtimes. What is the most likely root cause of the symptom? A. The vent pipe slope is incorrect, trapping condensate. B. The draft inducer is undersized for the BTU output. C. The blower speed is too low, causing overheating. D. The gas valve is supplying excess manifold pressure. Answer. Correct answer. A. The vent pipe slope is incorrect, trapping condensate. Explanation. Condensing furnaces require vent pipe slope back to the furnace to ensure proper condensate drainage. According to NFPA 54 and manufacturer installation instructions, improper slope traps water, restricting airflow and causing shutdowns. The furnace may go off on limit or pressure fault. This is a common install error, not a combustion issue. Question 19. Looking at the data on tool calibration, a technician uses a digital vacuum gauge during evacuation of a large system. He notes inconsistent readings when pulling below 500 microns and suspects a leak. He replaces hoses and fittings, but the issue persists. What should he do next to verify the vacuum readings' accuracy? A. Add a vacuum-rated oil to improve micron sensor response. B. Connect a second vacuum gauge at a different system location. C. Use nitrogen to push remaining moisture out of the system. D. Begin the recovery process to reset the refrigerant cycle. Answer. Correct answer. B. Connect a second vacuum gauge at a different system location. Explanation. According to HVAC school and NEVIC guidelines, vacuum gauge placement and sensor calibration are critical. Comparing two gauges ensures the sensor isn't faulty. Sensor contamination, poor location or isolation from the system can all lead to false low readings. Moisture removal and refrigerant cycles don't confirm gauge accuracy. Question 20. The interrelationship between hydronic and forced air systems becomes apparent in a large mixed-use facility. Technician Fiona discovers that the radiant floor heating system interferes with the cooling setpoint of the central air handler, causing occupant discomfort. What integration issue is likely at fault? A. The air handler has incorrect fan rotation direction. B. The zone control system lacks proper priority hierarchy logic. C. The radiant loop is undersized for peak winter loads. D. The hydronic pump is oversized, creating pressure imbalance. Answer. Correct answer. B. The zone control system lacks proper priority hierarchy logic. Explanation. When radiant and forced air systems operate simultaneously, control logic must assign priority to prevent conflicting calls. Per SIPS and ASHRAE integration guidelines, heating and cooling must be staged or interlocked. Lack of zoning logic causes simultaneous operation, leading to energy waste and discomfort. Fan direction and pumps wouldn't explain temperature overlap. Question 21. With the advent of energy benchmarking standards, technician Marcus is tasked with improving the efficiency of a rooftop valve system in a mid-rise office. The system uses demand-controlled ventilation and operates with consistent zone temperatures but consumes excessive energy during partial load. Marcus confirms all sensors are accurate and dampers are responsive. What is the most likely source of inefficiency? A. The cooling coil bypass damper is stuck in the open position. B. The supply fan is running at constant speed rather than being modulated. C. The economizer is introducing too much outside air. D. The valve boxes are undersized for peak loads. Answer. Correct answer. B. The supply fan is running at constant speed rather than being modulated. Explanation. Per ASHRAE 90.1 and DOE building efficiency guidelines, variable speed fans must reduce speed under partial load. A constant speed fan wastes energy during load demand even if zoning and temperatures are balanced. Economizers and bypass dampers affect temperature but not baseline energy use. Fan modulation is critical to N. Question 22. As demonstrated by a high-pressure system service technician Jorge is preparing to open a system containing R400 Tina. He dons gloves and goggles and confirms the pressures are within expected range. However, the discharge line feels significantly hotter than normal and the gauge reads 420 sig. What is the most important next step for Jorge to ensure safety? A. Vent the system slowly through a manifold to reduce pressure. B. Evacuate the refrigerant into a recovery cylinder rated for high pressure. C. Spray the lines with water to cool them before disconnecting. D. Wait for the compressor to cool naturally before attaching gauges. Answer. Correct answer. B. Evacuate the refrigerant into a recovery cylinder rated for high pressure. Explanation. R400 Tina is a high pressure refrigerant. Typical high side can exceed 400 sig. Per EPA 608 and OSHA 29 CFR 1910.147. LOTO procedures. Venting refrigerant is illegal and dangerous. The proper method is recovery using a DUT-approved high-pressure tank. Spraying water or delaying doesn't ensure containment or personal safety. Question 23. Throughout the course of analyzing an ice machine, technician Brooke notices long harvest times and reduced ice output. The pressures are within manufacturer specs and the system pulls into a proper vacuum during off cycles. However, she notes low superheat and minimal subcooling. What condition is most likely causing the reduced capacity? A. The compressor valves are leaking internally. B. The evaporator is undersized for the ambient load. C. The expansion valve is overfeeding the evaporator. The water distribution system is clogged with scare. Answer. Correct answer. C. The expansion valve is overfeeding the evaporator. Explanation. Low superheat indicates the evaporator is flooded, meaning the TSV is feeding more refrigerant than needed. Minimal subcooling supports that refrigerant isn't fully condensed. Overfeeding reduces evaporator efficiency and can lead to poor ice formation. Per SA's manuals and manufacturer diagnostics, e.g. mannitose, TXV adjustment or bulb repositioning is required. Question 24. From a historical standpoint, programmable thermostats were expected to improve energy efficiency. However, technician Telia notices repeated calls from customers with complaints of comfort fluctuations despite correct programming. Most issues arise during seasonal transitions. What is the most probable root cause of these complaints? A. Heat anticipator settings are too aggressive for current systems. B. Setback temperature swings are too large for system recovery. C. Batteries are weak, causing memory loss. D. Outdoor reset sensors are incorrectly placed. Answer. Correct answer. B. Setback temperature swings are too large for system recovery. Explanation. Large temperature setbacks require systems to run longer to return to comfort, leading to overshooting or undershooting during seasonal transitions. Per Energy Star and ASHRAE 55 guidelines, moderate setbacks ensure comfort and efficiency. Anticipators are outdated in modern digital controls. Outdoor reset affects hydronics, not standard HVAC cycles. Question 25. In contrast to typical compressor start issues, Feldman is troubleshooting the scroll compressor that fails intermittently after running for several hours. The contactor remains engaged, voltage is stable, and no high-pressure faults are recorded. The crankcase temperature is abnormally high. What should Feldman investigate to resolve the fault? A. Check for internal compressor insulation breakdown. B. Verify crankcase heater operation and thermostat cycling. C. Inspect the capacitor for bulging or leakage. D. Replace the contactor to prevent coil chatter. Answer. Correct answer. B. Verify crankcase heater operation and thermostat cycling. Explanation. A hot crankcase allows refrigerant migration, leading to liquid slugging or oil dilution, which can cause the compressor to shut off internally via protector. Scroll compressors require active crankcase heating, especially in off cycles. Per Copeland guidelines, heater failure causes intermittent failures after runtime accumulation. Contactor chatter would cause VOS, which isn't present here. Question 26. By evaluating a closed-loop geothermal installation, technician Riley notes that the system fails to reach set point during peak cooling. The ER readings are below manufacturer specs. Riley finds flow rates are adequate and loop pressures are within range, but loop fluid temperature is rising steadily. What is the most likely issue? A. The ground loop is undersized for building load. B. The reversing valve is stuck between modes. C. The purge cart failed to remove all air from the system. D. The superheater is overloading the condenser coil. Answer. Correct answer. A. The ground loop is undersized for building load. Explanation. If loop fluid temperature increases continually during operation, the system can't reject heat fast enough, pointing to an undersized loop field. According to HVACR GS manuals, proper ground loop sizing is critical for thermal balance. Flow and pressure being nominal confirms mechanical operation, isolating the issue to loop design. Question 27. Considering the evidence from a maintenance log, technician Nina observes that a packaged rooftop unit consistently triggers a high-pressure switch every summer. The coil has been cleaned regularly, charge verified, and filters replaced on schedule. However, pressure spikes still occur on hot afternoons. What maintenance step is most likely being overlooked? A. Fan motor bearings are dry and reducing airflow. B. Condenser fins are matted internally with embedded debris. C. The TSSV strainer screen is partially clogged. D. Supply duct static pressure is too low. Answer. Correct answer. B. Condenser fins are matted internally with embedded debris. Explanation. Surface cleaning may not remove embedded debris. Finned coils often require backflushing or coil splitting to clean inner layers. As per SMACNA and manufacturer guides, high head pressure during peak heat indicates poor heat rejection. If airflow and charge are confirmed, internal coil fouling is a common cause often missed during visual inspections. Question 20. The growing trend in connected buildings brings technician Omar to diagnose a zone ERF system controlled via cloud-based EMS. Clients report inconsistent zone temperatures despite accurate central set points. Omar finds the zones are frequently in heating and cooling simultaneously. What system feature should Omar investigate to correct this behavior? A. The discharge air sensor calibration. B. The simultaneous mode enablement logic. C. The condensate float switches. D. The inverter compressor speed configuration. Answer. Correct answer. B. The simultaneous mode enablement logic. Explanation. ERF systems operating in heat recovery or simultaneous mode rely on correct zone logic to determine refrigerant flow and mode. If zones are set to opposite modes without sequencing logic, the system struggles to maintain comfort. As per Dakin ER service manuals, central controller configuration and zoning priorities must be reviewed for mode comfort. Question 29. The traditional approach to ductless service involves individual head evaluation, but technician Lee discovers a 3-head mini split with 2 heads cooling fine and 1 barely operating. All heads share the same refrigerant line. Pressures and charge are normal. What should Lee check to identify the fault? A. The suction line insulation at the weak head. B. The electronic expansion valve specific to the malfunctioning head. C. The air filters for excessive dust accumulation. D. The float switch on the indoor coil. Answer. Correct answer. B. The electronic expansion valve specific to the malfunctioning head. Explanation. Each indoor unit in a multi-head ductless system has its own electronic expansion valve, controlled independently. If a head receives refrigerant but cannot modulate it correctly, poor cooling will result. According to Mitsubishi and Fujitsu diagnostic protocols, failure or control signal faults are common and require head evaluation. Question 30. In the absence of clear documentation, technician Derek completes a warrant compressor replacement. He finds evidence the original installer used flexible water line connectors instead of approved vibration eliminators. Derek is unsure whether to inform the client as the system is now working correctly. What is the most ethical and professional action Derek should take? A. Report the issue to his supervisor but leave the customer out. B. Note the condition in the invoice comments and inform the client. C. Ignore the issue since it's unrelated to the current repair. D. Contact the original installer directly for clarification. Answer. Correct answer. B. Note the condition in the invoice comments and inform the client. Explanation. According to HVACR best practices and the NATACA Code of Ethics, technicians must communicate system risks transparently to clients. Documenting and informing empowers the client to make decisions while protecting the technician legally. Hiding the issue or passing it to others violates professional integrity.